Welcome to Mitchell Maths. In this video we're going to have a look at graph transformations. So first we're going to have a look at what happens when you add a number to f of x, as in part A, y equals f of x plus 3. And we're also going to have a look at when you add a number to the x directly, which is shown in part B, where you have y equals f of x, in brackets x plus 4. Now, so what happens in the first one is your f of x just means a function of x, so it's like an equation which contains x. And what you're doing is you're adding 3 to all the values, which means that each y value is going to increase by 3. Therefore, if we want to draw this graph here, we're going to need to move it up in the positive y direction by 3. So it was 2 minus 3. If it goes up by 3, it's going to reach the x-axis. So we're going to get something a bit like this. It's not going to change in the... And we need to it's asked us to give the coordinates of the turning point. So the coordinates of the turning point, the x value doesn't change, it stays as 2, but minus 3 will now become 0. The next question, y equals f of, in brackets, x plus 4. Now, because it's in brackets, it's going to affect the x value. And what we need to think about is which way is it going to move? Is it going to move right in the positive x direction, or is it going to move left in the negative x direction? Well, if we think about it, if we're going to add 4 to all the x values, so for example, the x value here is 2. If we're going to add 4 to the x values, that value would become 6. And if we think of 6 will be around here somewhere. So instead, this part of the graph will be here, because we're adding 4 to the x values, which is going to affect the y values. If I want to get the same value as I did here, 2, I'd need to start at minus 2, because minus 2 plus 4, because remember, if you're adding 4 to it, is 2. So minus 2 would be the minimum point here. So when you add 4 to the x value, when you add a number to the x value, it always goes in the opposite direction. So if you add something, it'll go in the negative x direction to the left. And if you subtract something, it'll go in the positive x direction to the right. So in this case, I'm going to go 4 to the left. And I'll get something like this. And my minimum point will be minus 2. And the y value won't change, so it'll be minus 3. So we've looked at what happens if you add something to the y, or if you add something to the x. Now let's have a look at when we put minuses in. When we put negatives into these f of x equations, what we get is we get reflections. And for the first one, where we've got y equals minus f of x, what that means is all the y values which were positive will now become negative, and all the y values which were negative will now become positive. So if we have a look at this graph, it's going to turn out like this. Because the graph has flipped over, minus 3 has become a 3, all these positive values have become negative. The turning point is going to be 2, 3. So it stays the same, it's just the negative has become positive. And we can call this a reflection in the x-axis. Now let's have a look at B. This is where you minus the x. And this has a slightly different effect, because what will happen is all the negative x values would be positive if you take them away, and all the positive values would become negative. Therefore, you're going to have everything's going to flip round. So you'll get something like this. And the turning point is -2 because minus 2 is 2, as it was there. So it's -2 minus 3. So when we're minusing the x directly, we can say it's a reflection in the y-axis. So we've just gone through, so we've gone through the two reflections when you take away things and the two translations when you add either to the y or the x. Let's have a look at an actual, so not just a function of x, let's have a look at a graph, y equals x squared. And in this graph, it wants us to draw the new graph and give the coordinates of the turning point, so the stationary point that is. And the first one, we've got y equals x squared plus 4. So we're not adding directly to the x, that 4 is going to be added on to every value. So that means the graph is going to move in a positive up in a positive y direction by 4, which means we'll get something like this. And because all the values are 4 greater, here it goes through 0, 0, here it'll be through 0, 4. That's the turning point. In this one, we've got y equals x minus 3 squared. So in this one, we're taking away from the x directly. Now, if you remember what we said, when you add to the x, you go in to the left or the negative x direction. If you take away from the x, you go in the positive x direction, because if you think 3, well, 3 minus 3 would be 0. 6 minus 3 would be 3. 6 minus 3 would be 3. So all the values are going to shift to the right. Therefore, we're going to have something that looks like this. And the coordinates will be 3, 3, 0. Sometimes you get like not conventional graphs, a bit like what we've got there. Y equals f of x, point A has the coordinates minus 3, 5. And these have two transformations. So let's have a look at what's going to happen. So in the first one, it's minus f of x, so we're going to first minus it. If we minus the f of x, what that'll do is it'll flip it in the x-axis, and then we're going to take away 1, which will move it down 1 in the negative x direction. So after 1, it would after the minus, when we flip it, it'd look a bit like this. And then we're going to move it all down 1. So what we'll get is we'll get something that looks a bit like this. And it won't quite reach the x-axis. It'll just be a bit above that. And this point here, well, when we originally reflected it, it would have been minus 3, minus 5. But because we've moved it down but 1 further, it'll be minus 3, minus 6. So minus 3, minus 6. And for this one, well, first of all, we've minus the x, so the x's are all going to switch round. That'll mean that the graph would look a bit like... So if we minus the x, it would look like this, because it would be reflected in the y-axis. If we minus the x, it's reflected in the y-axis. But then we're going to plus 2, and because it's in brackets, that means it's affecting the x, which means that everything, because we're adding to the x value, everything's going to be shifted in the negative x direction to the left. So what we're going to end up with is something like that. And this point here, well, originally it would have been 3, 5 when it had been reflected in the y-axis, but then we've taken away 2 off the x value, so it'll be 1, 5. Right, so those two questions show you what happens when you do two transformations. Just think about what they both do individually and then put them together to get your answer. And also think about the order as well. Right, sometimes you need to describe transformations, so we need to describe the transformations on this graph. So curve A to curve B. Well, what we can see from curve A to curve B, it's been moved up by 9, and that's just a translation. So we'd say translation, and you by vector, and the vector will be 0 and 9 because it goes no units in the x direction but 9 in the positive y direction. If we have a look at curve B, that's curve C to curve A. Well, again, that's another translation, only this time it's moving in the x direction. So that'll be translation by vector, and it'll be, so it's gone from 2 to -5, so that's a total of -7. It's moved 7 units left. And it'll be 0 because it's in the same, it's got the same y coordinate -8. And part C is curve C to curve D, where we can see that all that's happened is the negative y values become positive. So it's been, that's a reflection, so reflected in the x-axis. Okay, so those are your those are your 3 transformations for those curves. Right, thank you for watching. I hope you found that helpful. If you liked the video, please hit the subscribe button. And for practice questions, please visit www.mitchellmathsandscience.com. The link is in the description.